What if someone told you that a few lines of code could potentially bring down an entire web application? Sounds dramatic, right? It is. This is the power of SQL injection, a significant threat to web applications that use SQL databases for data storage. So what exactly is SQL injection? It's a type of cybersecurity attack that occurs when an attacker manipulates an application's SQL query by injecting malicious SQL code into user input fields. This can lead to unauthorized access, retrieval, or even manipulation of data. Now, let's delve deeper into the various types of SQL injection attacks. First up, we have the classic SQL injection. This happens when an attacker directly injects malicious SQL code into user input fields. The application, if not properly armed to validate and sanitize input, can be manipulated by the injected code, leading to unauthorized access. Next, we have union-based SQL injection. Here, the attacker uses the union SQL operator to combine the results of the original query with those of the injected query. This trick can be used to extract data from other tables in the database. Then there's blind SQL injection. In this type, the attacker doesn't directly see the results of the injected SQL query. Instead, they infer information based on the application's response. It's often categorized as Boolean-based or time-based, where the attacker crafts queries that rely on true-false conditions or cause delays in the application's response. Time-based blind SQL injection involves injecting SQL queries that cause delays in the application's response. By observing how long it takes for the application to respond, an attacker can infer whether the injected condition is true or false. Error-based SQL injection, on the other hand, is all about triggering errors in the SQL query. These errors can reveal details about the structure of the database, assisting the attacker in their infiltration. Out-of-band SQL injection is a clever technique where the attacker retrieves data through a different channel than the one used to inject the malicious SQL code. This could involve techniques such as DNS requests or HTTP requests to an external server controlled by the attacker. Lastly, there's second-order SQL injection. Here, the malicious input is stored in the database and used later in a different context, leading to potential vulnerability. So, how do we prevent these attacks? Developers should use parameterized queries or prepared statements, validate and sanitize user input, and implement proper access controls. Regular security audits and testing, including penetration testing, are also crucial. In conclusion, SQL injection is a significant threat that can come in various forms. Understanding these types and implementing the right preventive measures can go a long way in securing web applications. Stay safe, stay secure.